Hi everyone, here is our last short little video just to show you an example of a word problem having to do with the ellipsis. Alright, one of the most common, well not most common I suppose, but one application of an ellipse is something called the Whispering Gallery, which we actually have one at the Museum of Science and Industry in Chicago. If you've never been, it's pretty awesome. There is this room that's the shape of an ellipse, and there are 2 points in that ellipse where no matter where a person is standing inside that ellipse, if they whisper or speak as quietly as they think, if you're at those 2 points, you can always hear them. And that's why it's called the Whispering Gallery, because you can whisper from one section, but if you're standing at those 2 points, you can hear it louder than a whisper. And those 2 points in the room are the foci, the focus points. So like I said, those points, they're kind of valuable points. Meaningful, I should say. So, the Whispering Gallery in the Museum of Science and Industry in Chicago is 47.3 feet long. There's a picture of it. Like I said, those 2 points where you can hear everything. And the distance from the center of the room to the foci is 20.3 feet. Find an equation that describes the shape of the room, and then how high is the room at its center. So, just like with the parabola that we talked about yesterday, with ellipses, when you have word problems, you can place those ellipses wherever is easiest on the coordinate plane so that you can work with it. And just like with a parabola, the easiest place to put it is at 0, 0. So what I usually like to start with is on my coordinate plane here. I put the center of my ellipse at 0, 0. 0, 0 right there. And that way, I can hopefully draw the ellipse and start to get a sense for what these numbers mean and use them in my equation. Okay. It says that the Whispering Gallery in the Museum of Science and Industry is 47.3 feet long. So I'm going to use this, the x-axis, to represent my length. So 47.3 feet long. Whoops, that's in total. Right, so like from one vertex to another vertex, let's say, that total distance would be 47.3 feet. Well, that means I can do halfway on each side. So half of 47.3, throw it in the calculator if you need to, is 23.65. So I would have positive 23.65 and negative 23.65. And this is going to form kind of the general shape, that was awful, of my ellipse. Something like that, down to here, and then back the other way, and then to here. I'm awful at drawing, but you get the idea. That's an ellipse. Okay. Then it says the distance from the center of the room to the foci is 20.3 feet. So foci are always inside of your ellipse, and it says from the center to the foci. So this distance here is, in fact, 20.3 feet. Find an equation that describes the shape of the room. Well, to start, just based on how I've decided to draw this out, my equation, the vertices are going to be on the x direction, so it's going to be this format, x squared over a squared plus y squared over b squared equals 1. And I know a because a is the distance from the center to my vertex, and that's what this 23.65 represents. So I can plug that part in, x squared, 23.65 squared. It's the b squared that I really need to know, and it's not given to me, but it did give me the foci distance. So this right here is telling me c is 20.3. Anytime you have your foci distance, you should be able to use that equation, b squared equals a squared minus c squared, to calculate your b value. So in this case, b squared will equal 23.65 squared minus 20.3 squared. And we can use our calculators to calculate that out, but it will end up being 147.233, and that's for b squared, right? Because we might as well just leave that as b squared instead of having to do double the work. So now my equation, again using my calculator to evaluate this piece, I would get 559.323 plus y squared divided by 147.233. And that equals 1, always. So there's my equation. Okay. The second question here is how high is the room at its center? So we're going to use the y-axis as our height, and what it's basically asking for is this value right here, this height, right, which is b. And since I already know b squared, and I know b squared is 147.233, I can just square root that value, and that will tell me the height. And so if I square root this, it's about 12 point, let's get this more exact, 12.134, round to 3 decimals, and that's in feet. So there's the height of the room at its center. Right. So a lot of these ellipse problems, again, just try and go off of the xy plane. Keep in mind what the different numbers mean. This problem, all the numbers that we were given represented A and C, and then we could find B. But sometimes they give you points on the ellipse. Remember, if you're given a point, like let's say here, on the ellipse, that's the point x comma y. That's where we would take that point and plug it in for x and y. So just bear in mind, every word problem is going to be a little different. Draw yourself that picture, and hopefully that'll help you out. Alright, if you have any questions, make sure you write them down. Answers to the even problems in the homework are up on Canvas. If you have questions, email me, or, like I said, write them down, ask me tomorrow. Thanks for watching. See ya.